Hello everyone, and this is Sandeep. You are watching Samyan's Academy. Okay, in this session, we are going to discuss about magnetic field around this coil. Okay, let us start with one experiment. Okay, now we start with this experiment. Take the current carrying circular loop, and now you sprinkle the iron filings around the circular coil uniformly. Okay, like this, you sprinkle the iron filings around the circular coil uniformly. Now you tap the seats few times. Now you see all iron filings. You see the pattern of iron filings now. Observe the pattern of iron filings around the current carrying circular loop. So observe the pattern of iron filings. Okay. At the center you observe the pattern of iron filings. How it look like? They look like as straight line. Okay. At the current carrying circular loop, all iron filings are in concentric circles. When you move away to these concentric circles, the lines becomes bigger and bigger and becomes straight at the center. Okay, so from this observation, we know that when the current is flowing through this coil, we can see the pattern of iron filings. Okay, how the iron filings align themselves at the current carrying circular loop and at the center of the concentric circle, at the center of this circular loop. Okay, iron filings align themselves in concentric circles around the circular current carrying circular loop. Okay, current at the current carrying circular loop, all iron filings align themselves in concentric circles. As we move away from this, as we move away, the concentric circles becomes bigger and bigger. At the center, the lines become parallel. Okay, here we can observe the all magnetic field lines are aligned themselves in straight line. Now you see, from this observation, we conclude that the magnetic field lines are circular near the current carrying loop. As we move away, the concentric circles are become bigger and bigger. At the center, the lines are straight. At the center, all the magnetic field lines are in the same direction, due to which the strength of magnetic field increases. Now you see, yeah, this is a plus terminal and this is a negative terminal. We connected with plus terminal of the battery and minus terminal of the battery this side. Then current will move from the positive terminal to negative terminal like this in the anti-clockwise direction, right? So now how we can take this direction of concentric circles near this current carrying conductor? By using the right hand thumb rule. Now you see, in this coil the current is moving in the upward direction here. Observe the current direction in this circular loop. So observe here, right? The current is moving in upward direction here. Take your right hand and stretch your thumb in the direction of the current. The curling finger indicates the direction of magnetic field lines. Now here we can observe the all field lines take this path. Okay, so all field lines are moving in anti-clockwise direction. When current is moving in this way, so when you come to here, now current is moving in downward direction. Here current is moving downward direction, right? So when you observe the pattern of these field lines, how will you decide the direction of the field lines? Taking the right hand thumb rule. You stretch your thumb in downward direction. The curling finger indicates the direction of the field lines. Now all field lines are moving in this direction, right? All field lines are moving in clockwise direction. Okay, all field lines are moving clockwise direction. So here the when current is moving upward direction, all field lines are taking in concentric circles in the anti-clockwise direction. Okay, so now you observe, when you move away to the center, the all concentric circles becomes bigger and bigger. At the center, it becomes straight line like this. Now you see, direction of all field lines at the center, all are in the same direction. Means because of these field lines here, all field lines are in the same direction. So due to which the strength of the magnetic field is increases. If all field lines are in the same direction means due to what? Due to this, the strength of the magnetic field increases. Yeah, if field lines are like this, some of the field lines are coming front of the plane and some of the field lines are going into the plane. Suppose if it is doing like this, all field lines are cancelled to each other, the net magnetic field will become 0. But in this case, all magnetic field lines are parallel to each other and all are showing the same direction. Means all field lines are in the same direction. So due to which the strength of the magnetic field increases at the center of this circular loop. Right. Now using the right hand rule only, we can see the direction of the magnetic field lines. Now you see, now this is the circular loop, right? The current is moving in anti-clockwise direction. You fold your finger in anti-clockwise direction. You fold your finger in anti-clockwise direction like this. The current moving direction, you fold, yeah, you fold your fingers in the direction of the current. In the circular loop, the current is moving in anti-clockwise direction. Now this thumb indicates the direction of field lines, so which indicates the north pole, right? Everyone remember. Suppose this is a circular coil. You take the direction of the circular coil with the folding your fingers, right? These fingers now you assume as direction of the current in the circular coil like this. Okay, this thumb indicates the direction of the magnetic field line. So this thumb indicates the north direction of the magnetic field lines. Okay, now in this case you see, in this case the current is moving in clockwise direction. Okay, my thumb is pointing towards inside the plane, means that side of the plane we have a north pole and the front of the plane we have a south pole. Like that also we can assume, right? Now the magnitude of the magnetic field produced at the center, when you take the center here, let us say this is a point P. At the center, the magnitude of the magnetic field we are taking. Magnitude means the value of the magnetic field. Okay, the value of the magnetic field depends on how much current is flowing through this circuit, and also it depends on the distance from the circular coil, and also it depends on the number of circular turns. Okay, so previously we observed that if you take many circular turns in the circular coil, the magnetic field increases. Okay, if you increase the current in this circular coil, the magnetic field at the point P also increases. Okay, yeah, now you see, this is a circular coil. Okay, and the magnitude of the magnetic field at the center of the coil depends on three things. So I am taking the P point here, right? Okay, the magnitude of the magnetic field at the center of the coil is depends on three things. Okay, first thing is the magnitude of the magnetic field is directly proportional to the current flowing through this circular coil. If the magnitude of the magnetic field means the value of the magnetic field at the center of the coil is directly proportional to current flowing through this circular coil. When current is increases, the magnetic field produced at this point P also increases, and also it is inversely proportional to radius of the circular coil. Okay, it is inversely proportional to radius of the circular coil. Means if you take the big circular coil, the distance from this center is increases. Okay, the point P, when you take the big circular coil, okay, the distance is increases. If you take the more radius, the P point is very far from the circular coil now. Okay, when you take the big radius of the circular coil, then what will happen? The magnetic field produced at this point P is decreases. Okay, when you take the small circular coil, the magnetic field produced at its center is increases. If you take the big circular coil, the magnetic field generated here is less. Okay, now, and also it depends on number of turns, how many turns you are taking. Okay, while winding the copper wire, how many rotating you are doing. So first, number of rotations means number of turns. How many turns are there? Many turns we have taken. And also this magnetic field is directly proportional to number of circular turns. If you are taking more number of circular turns, we can get more magnetic field at its center. If you take very less number of turns like this, okay, we will get only less magnetic field at its center. From this observation we confirm that the magnitude of magnetic field produced by a current carrying circular loop at its center is directly proportional to the current passing, inversely proportional to radius of the circular loop, and directly proportional to number of turns. Okay, and this is about magnetic field due to a current through a circular loop. If you like this video, please subscribe, share and comment, and don't forget to subscribe. Okay, have a nice day. Thank you for watching. Bye.